Today we are going to see about sleeve or muff coupling. So it is the part of transmitting the power from one shaft to the another shaft. So sleeve coupling consists of hollow cylindrical sleeve. So இது வந்து என்னன்னா muff coupling சொல்லலாம் இல்ல sleeve coupling சொல்லலாம். Rigid type, அதாவது ஒரு length shaftல we are going to transmit the power from one place to the another. Shall we see the one example for that?
Yes. Design a muff coupling to connect two shafts transmitting 40 kV at 120 rpm. The permissible shear and crushing stress for the shaft and key material are 30 MPa and 80 MPa respectively. The material of muff is cast iron with permissible shear stress of 15 MPa. Assume that the maximum torque transmitted is 25% greater than the torque.
So
the principle of muff coupling. So it consists of three main parts: sleeve or muff, shafts, and keys. So sleeve is a hollow cylindrical component made up of cast iron or steel, covers the ends of both shaft. Shaft, the two aligned shafts connected together. A rectangular metal piece is inserted between shaft and sleeve, preventing slipping and transmitting torque.
So initially the power is given as a 40 kilowatt and for power create ஆகுதுனாலே it has to be in a running condition. So that is 120 rpm. So shaft under the crushing segment, that is shear stress is 30 Newton per mm square and sigma, that is crushing stress is 80 megapascals. That is also 1 megapascal is equal to 80 Newton per mm square. So sleeve, the main concept is sleeve. Sleeve is going to be held up in the shaft at the upper part. So it should be at 5 Newton, 15 Newton per mm square. So what is the first step?
As a first step of solving this sum, we have to find the diameter of the shaft. So before finding the diameter, we should know the T mean. As given the sum as T max is 1.25 times of T mean. So first we will be substituting the formula with the formula of P is equal to 2 pi nt by 60, and we will be solving it, and we will be finding the T mean and multiplying with the 1.25 to get the T max, and we will be substituting the T max value in the formula, which is T is equal to pi by 16 tau T cube.
So that is we are going to find out the maximum torque, that is a torsional moment, that is T, that is pi by 16 is a constant value for the torsional moment. So tau is torque, that is crushing inside. So and D is diameter. We are going to find out the diameter. So dimensions of the sleeve is D is equal to 2D. That is in P is a design data book. So we get the formula from here. D is equal to 2D. So in the page number 7.133 in design data book, we will get the formula D is equal to 2D. So we are going to find the entire length. Now we have to plus 30. Of the half segment now we don't want to add 13 mm. So length is equal to 3.5D. So we get a value of D is 87. So 87 is an odd number. Diameter எப்பவுமே வந்து even number இருக்கும். So we take it as 88 or 86. So from the gate point of 88 we will get capital D, that is the diameter of the sleeve. Outer diameter is capital D, inner diameter is small d. So total length is capital L. So in the sleeve of muff coupling we are going to find out the design concept. Design is safe or not through the three segments. One is design of key with the dimensions. We get it from 5.16 page number, and for the same we will substitute all the diameter, outer and inner diameter. We will get, for example, the crushing stress is 30 now, the 30 kilo design is safe, or otherwise design is not safe. We have to reconstruct the length and diameter of the key. So for the diameter what we get as actually, so for the same diameter we will get the key. If the design is not set now, we have to reconstruct the key diameters. So another thing is we have to find the shear failure or shear segment through the torsional movement and the crushing failure of the key. So the main thing is shaft is the stable one, coupling and the key is the rotational part. So and the power transmit பண்ணும்போது so keyயும் couplingum வந்து design safe ஆ இருந்துச்சுன்னா power will constantly transmit from one place to the another. So this is the basic and concept of sleeve or muff coupling. So two shafts are inserted in above and opposites of the sleeve side. ரெண்டுமே வந்து ஆப்போசிட் இருக்குது இங்க இல்லைங்களா? ஸோ இந்த சைடு இருக்கும். ஸோ சென்டர்ல இருக்க லென்த்தை மட்டும் நம்ம பார்த்தா போதும். ஸோ ஒன் ஷாஃப்ட் ரொட்டேட்ஸ், டார்க் இஸ் permitted to go other side. அப்போ ஒன்று ரொட்டேட் ஆச்சுனாலே கப்ளிங் மூலியமா அதர் பார்ட்டும் ரொட்டேட் ஆக ஆரம்பிச்சிடும். ஸோ வில் கெட் தட் பவர் ஃப்ரம் ஒன் place to the another. ஸோ அட்வான்டேஜ் வந்து என்னன்னா லோ காஸ்ட். ஸோ மஃப் கப்ளிங் இஸ் இன் லோ காஸ்ட் கம்பேர்ட் டு த அதர் ஒன். இட் இஸ் ஸ்ட்ராங், காம்பேக்ட் அண்ட் ஸ்ட்ராங். ஸோ டிஸ்அட்வான்டேஜ் வந்து என்னன்னா ஷாஃப்டோட அலைன்மெண்ட் ப்ரிசைஸா இல்லை அப்படின்னா இட் கான்ட் டிரான்ஸ்மிட் த பவர். தேங்க்யூ.